Let a, b, c, and d be non-integer real numbers. The numbers a, b, and c in this order form an arithmetic progression. The numbers b, c, and d in this order form a geometric progression. If a plus d equals 37 and b plus c equals 36, find d. Here we have the numbers a, b, c, and d. Since the number b appears in both sequences, let's use b as a base. So a, b, and c form an arithmetic sequence. Let's say that the common difference is called r. b would just be equal to b, but a would be equal to b minus r, and c would be equal to b plus r. And in the geometric sequence, b would just be b, but c can be represented as bq. Q can be the common ratio of the geometric sequence, and d can be represented as bq squared. So c can be represented in two ways. b plus r is equal to bq. If we isolate r, it's the same thing as b times q minus 1. Now we have our first equation that represents r in terms of b and q. Now let's substitute this into our equation for a. A is equal to b minus r. This is equal to b minus b times q minus 1. This is equal to b minus bq plus b, which is equal to 2b minus bq, which is equal to b times 2 minus q. Now we can use these two equations. b plus c is equal to 36. Let's write c in terms of b. C is b plus r. But again, r can be represented as b times q minus 1. This is equal to 36. We can factor out a b, and we get b times q plus 1 is equal to 36. So b, represented in terms of q, is 36 over q plus 1. Now, what about our next equation? A plus d is equal to 37. A is represented as b times 2 minus q, and d is represented as bq squared. 2b minus bq plus bq squared is equal to 37. We factor out a b to get q squared minus q plus 2 is equal to 37. So b is equal to 37 over all of that. Now we have two equations both expressing the same thing, b. We can combine them. 36 over q plus 1 is equal to 37 over q squared minus q plus 2. Let's move all the terms to the left side. We can factor this. 36 q squared is equal to 9q times 4q. And we know that the second term of each binomial must be negative. If we put in 7 and 5, it will work here. So this can be factored to be 9q minus 7 times 4q minus 5 is equal to 0. So now we have two possible solutions for q. Q can either be 5/4 or 7/9. Now our final goal is to find d. D is equal to bq squared. Now we can test the two values for q. If q is equal to 5/4, we get 36 over 9 over 4 times 25 over 16. That is equal to 16 times 25 over 16, which is equal to 25. And if q is equal to 7/9, we get 36 over 16 over 9 times 49 over 81. This is the same thing as 36 times 9 over 16 times 49 over 81. We are left with 49 over 4 for d. The problem says that a, b, c, and d are non-integers. It means d cannot be a 25. So d must equal 49 over 4 since that's not an integer. So our answer is d is equal to 49 over 4.